Hey everyone, and welcome. Today we're going to jump into one of the most important, and I think one of the most interesting chapters in geometry, lines and angles.
Okay, so here's what we're going to do today. We'll kick things off with why the stuff even matters. Then, a super quick review of angles, just to get our brains warmed up. After that, we'll tackle the two big rules for today, the linear pair rule and vertically opposite angles. And to wrap it all up, we'll solve an exam-style problem together, step by step. Sound good? Let's do this. First up, you might be wondering, why do I even need to learn this stuff? Well, let's take a look at just how much lines and angles are all around us in the real world.
I mean, just think about it. The house you're sitting in right now, an architect used angles to make sure it's strong and doesn't fall down. When you study science, you see them in ray diagrams for light. Engineers, they're constantly using angles to figure out forces on things like bridges. And even out at sea, navigation depends on angles to find a ship's distance from a lighthouse. So yeah, having a solid grip on lines and angles is, well, it's absolutely crucial. All right, let's dive in.
Okay, before we get to the new stuff, let's hit pause and do a quick review. We've got to make sure we're all speaking the same language, right? So let's revisit one key idea. So adjacent angles. The definition sounds a bit formal, but it's really just three simple rules. For two angles to be adjacent, they have to check three boxes: a common vertex, a common arm, and their other arms have to be on different sides.
And this picture shows it perfectly. See? We've got a common vertex right here at B. Then there's the common arm, this ray BD that they both share. And finally, the other two arms, BA and BC, are on opposite sides of that shared arm. Check, check, and check. So angle ABD and angle DBC are adjacent.
All right, time for our first big tool for our geometry toolbox. This is called the linear pair rule, or axiom. And trust me, this one is a game changer. Anytime you see a straight line in a problem, your brain should immediately think of this rule. Let's see what it's all about.
So just imagine you have a straight line, like AB here, and then a ray, OC, just stands right on top of it. What happens? Well, that ray basically splits the straight line's angle, which we know is 180 degrees, into two smaller angles that are right next to each other, angle AOC and angle BOC.
And here's the rule. It's super simple, but so powerful. If you have that situation, the sum of those two adjacent angles, angle AOC plus angle BOC, will always be 180 degrees. No exceptions. That's the linear pair axiom. Make sure you remember this one.
And what's cool is that this works backwards too. So, if you see two angles right next to each other, and you add them up and get exactly 180 degrees, then you know for sure that their outer arms, their non-common arms, form a perfectly straight line.
Okay, now things get really cool. We're going to take the linear pair axiom we just learned and use it to prove another super useful theorem. This one is all about what happens when two straight lines cross each other.
So, you see here how lines AB and CD are intersecting at point O? This creates four angles. The angles that are directly opposite each other, like a mirror image across the center, are called vertically opposite angles. So AOC and BOD are a pair, and AOD and BOC are another pair. Now, let's prove something amazing about them. Now, this is a common tricky point, so watch carefully. It's a really neat proof. Step 1. Just focus on the line CD and the ray OA standing on it. See that? What rule can we use? The linear pair axiom. So angle AOC plus angle AOD has to be 180 degrees. Got it? Step 2. Okay, now ignore that for a second and look at the line AB and the ray OD standing on it. Again, it's a linear pair, so angle AOD plus angle BOD also equals 180 degrees. Step 3. Now think about it. If AOC plus AOD equals 180 and AOD plus BOD equals 180, then that means that AOC plus AOD must be equal to AOD plus BOD. And since angle AOD is on both sides of that equation, we can just cancel it out. And what are we left with? Angle AOC equals angle BOD. Boom, we just proved it. Vertically opposite angles are equal.
Okay, we've got our tools, the linear pair axiom, and the vertically opposite angles theorem. Theory is great, but now it's time to actually use them. Let's solve a problem together, step by step. You've got this. All right, here's a classic exam-style question. Look at the figure. We have two lines, PQ and RS, intersecting. They tell us the ratio of angle POR to angle ROQ is 5:7. Our mission, should we choose to accept it, is to find the measure of all four angles.
So what's the very first thing you should notice here? Look for a straight line. See line PQ? Angles POR and ROQ are sitting right on it. That means they form a linear pair. And what do we know about linear pairs? Right, they add up to 180 degrees. So angle POR plus angle ROQ equals 180. That's our first step, our key to unlocking this whole problem.
Okay, now we use the ratio they gave us, 5:7. So the total number of parts in our ratio is 5 plus 7, which is 12. We need to divide the total 180 degrees into 12 equal parts. So angle POR gets 5 of those parts. That's 5 divided by 12 times 180, which gives us 75 degrees. And angle ROQ gets the other 7 parts. So 7 divided by 12 times 180, and that's 105 degrees. Awesome! We've already found 2 of the angles.
And now for the other two? This is the easy part, a piece of cake. We just use our vertically opposite angles theorem. Angle SOQ is directly opposite to angle POR, right? So it has to be the same. That's 75 degrees. And angle POS is directly opposite to angle ROQ. So that one must be 105 degrees. See? No more hard calculations needed. And there you have it. All 4 angles are calculated. We got 75, 105, 75, and 105. And we did it all using just those 2 simple rules working together. See how they connect? Fantastic job!
That was great. Okay, let's do a super quick recap of the main points, and then I've got a really important exam tip for you that will help you score those full marks.
So, to sum it all up, today was all about 2 big ideas. First, the linear pair axiom. 2 adjacent angles on a straight line add up to 180. Second, the vertically opposite angles theorem. When 2 lines cross, the opposite angles are equal. These 2 are the absolute building blocks for this entire chapter. Master these, and you're well on your way.
All right, and here it is, my #1 exam tip. Listen closely. Whenever you write an equation in geometry, you must always write the reason in brackets right next to it. Don't just write angle A plus angle B equals 180. You have to write angle A plus angle B equals 180 and then in brackets, linear pair axiom. This tells the examiner that you know why you're doing each step. It's such an easy way to secure full marks.
Okay, here's a final little puzzle for you to think about. If 2 lines intersect, and I only tell you the measure of one of the 4 angles, how many more calculations do you really need to do to find the other 3? Give that some thought. Keep practicing. You're doing an amazing job. And I'll see you in the next part of our series on lines and angles.